All right, let's get started. Good afternoon. My name is Ada Wu. Welcome everyone to the Computational Psychometrics session at NCME, virtual summer session. Today with us, we have a really good lineup of research papers that are going to be presented to you. First of all, I would like to thank Alina von Davier for organizing this particular session. So today we have four presentations for you. We have a presentation from Alina von Davier and Bert Settle on dynamic testing and computational psychometrics. And I believe Alina will also give a little bit background on what is computational psychometrics if you need that information. Next on the docket is John Whitmar. He's going to talk about learning analytic and self-assessment. And then Yuqi Huang is going to talk about the project his team work on automated generation for English reading comprehension assessment. The system is called Sphinx. And then we'll hear from Bruno Zumo on his comment as discussing. We will save quite a bit of time for Q&A. So throughout the presentations, please feel free to message me using chat. If you have questions, we'll save it until the end, or you can just ask the presenters at the end if you please. So each presenter, you will have 17 minutes to present, and then we want to save quite a bit of time at the end for Q&A and have some interaction with folks online. So let me just pass it on to Alina and Bert.
Thank you, Ada. I'm gonna share my screen. Can you see my screen?
Not yet, Alina.
Not yet.
Jeez, okay. It's a new computer, so it looks like I am not able to share right now.
Do you want me to try and I'll...
Yes, please. Why don't you do that? And then you move the slides until I get the privacy settings here set up. Yeah.
I can see it now.
Perfect. Thank you, Bert, for doing that. Well, so it's really a pleasure being here. Thank you, Ada, for the introductions and for setting us up. I am Alina von Davier, and I am with Duolingo, in particular with the Duolingo English test team. And this presentation and the symposium has been submitted a few months ago before some of the changes for many of the presenters here. So what you will see today is in some respect a slight pivot from the original intention. So that being said, I will talk today about the emerging trends in assessment. I will talk about computational models, data-driven algorithms for test development in general, different AI-powered capabilities. And I will talk about something that in the last 6 months or so, I've been thinking quite a lot about, which is the need for integration for infrastructure, frameworks, and the tools that we develop. I will also talk a little bit about other trends, such as the online testing with remote proctoring, that's obvious now in COVID, and how computational psychometrics is one of these integrative frameworks that can provide the glue for many of these trends. One of the examples that we will present today is the Duolingo English test, and my colleague Burr will do that part of the presentation. Thank you. Go next. Thank you. So as part of the emerging trends, I mentioned before that I've been thinking quite a lot about what it takes to put in place an assessment that is built dynamically and it works together across different tools. And I've been thinking in terms of two two categories of tools that we need to have in place. One are integrative frameworks, and then the other one will be the tools themselves. As part of the integrative frameworks, I'm mentioning a few here that are relevant for different parts of the test development. One would be construct taxonomy. In our case at Duolingo, this is Common European Framework, but in other circumstances, this can take different other forms, such as common standards, common core standards in the United States for K through 12. Another example of an integrative framework is a computational psychometric framework that would allow us to put different pieces together in a coherent way. Another way of looking at integrative frameworks is to think of the database alignment. How do the data should actually be, the databases should be aligned, should have a schema for data collection and applications so that we can extract information in real time, process it in real time, and evaluate it in real time. And then there are other things that are necessary, often is to interact with others. So data exchange standards is one of these frameworks. APIs and platforms. Obviously, platforms are key for most of these computer-based assessments. Next, please. The other part, so I said before, there are two parts. One is the frameworks, the integrative frameworks. The other one are examples of tools that provide it to be quite useful for the development of assessments in the 21st century. For example, one of them is how to align the content and how to tag the content for learning resources and test items. So if you want to create a test, you have a clear taxonomy, and you are either developing resources or taking them from different sources, and now you want to tag them to the relevant attributes of the construct that you want the students to learn or to display their learning, as is the case in assessment. Another area that will be also discussed today by Yuchi is content generation, both for learning resources, but also for test items. Other areas are scoring, automatic scoring. Other tools that have been shown to be very useful are personalized diagnostic and recommendation engines. Obviously, analytics as automatic as possible, and John will talk about that today, and how the analytics can be useful. And delivery, of course, is also relevant. In the case of assessment, delivery could mean be able to deliver the test online and have it remote proctored. That's one feature of the delivery of an assessment that it requires AI-powered algorithm and capabilities to ensure security of the test and the validity of the test. Next slide, please. So what is computational psychometrics, and do we really need another name? Next, please. Well, not necessarily. We don't necessarily need another name. The choice seems to be for using it in computational physics, linguistics, science, biology, and so on. And the reason for that is that nowadays we have both really good algorithms that are data-driven and the big data sets that are associated with this algorithm that make them really powerful. So you don't have to use the computational psychometric as a full concept, but it's easier to talk about it and to communicate with others what you mean. So let's talk a little bit more about what I meant and how I define computational psychometrics when I introduced it. And it hasn't really changed much since 2015 when I introduced it at ICML International Meeting of Machine Learning. So next, please. So computational psychometric is a framework, an integrative framework that is psychometric centered, meaning that it deals with psychological and educational measurement. In particular, and I need to emphasize that for the engineers among us, to emphasize the fact that it's focused on measuring latent variables. And part of this framework on the psychometric centers means that we look at reliability, validity, fairness, generalizability. And that it also includes more than just the test. We also look at processes, at ancillary type of data that could be incorporated for, say, career navigation or for other purposes in our research study and focus. Computational psychometric as a framework is also theory-based. It's interdisciplinary, using a science-based definition of models and construct and understanding of how the construct should be measured in authentic tasks in the 21st century. And it is inspired and always follows or required to be followed frameworks, a framework for such as evidence-centered design for assessment, or such holistic frameworks such as the SAIL framework from Northeastern University or from other companies. It is also though data-driven. So the first two are typical for psychometrics in general. But it's data-driven, so large-scale, high-dimensional, real-time, in real-time collected and analyzed data. Data sources can also be of different types, and it does for education especially, it exemplifies big data. And it's algorithm powered, so adaptive, computationally efficient, and it provides interactivity and feedback in real time under different instantiation, be that in a learning system or in an assessment by providing diagnostic models, diagnostic profiles and recommendations. Next, please. So what is it actually? It's a multidisciplinary, multimodal approach. Next, please. That starts, as I mentioned before, with cognitive learning and psychological measurements. It looks at higher level constructs, it looks at feature extractions, and the basis of all of this is the rich data that we are nowadays able to collect in assessments that take place online. So we collect much more than just the correct or incorrect responses. We have the capabilities to collect timing information and other process information about how the students actually think about their responses. Next, please. One of the insights that in the past few years I've been talking more about it, and we also have a paper on what we call the data cube, is the idea that in assessment and in the process of developing items and thinking about aligning the content needed with taxonomies and different levels of abilities and with the student responses, that in that context, we need to think of the content as data and need to treat it as data. Taxonomy standards and knowledge maps become data in this framework, and that makes our life so much easier because it will help with tagging, it will help with classification, it will help us build the Q matrices for diagnostic, and it's just, once we start thinking in this way about our content, a lot of doors opened with respect to what we can do. So it allows us to combine the item and instructional content metadata and align it with the testing instrument and the instructional tools through the taxonomies. Next, please. One observation, and this is really new given that I've been with Duolingo just 2 weeks, I'm thinking that from the arsenal of psychometrics, and if we look at that as a you know, almost like a carpenter bag with a lot of tools. It appears to me that we might want to take a second look at general linear and nonlinear mixed models. Because in this dynamic testing environment, we might want to estimate the parameters for both the items and people's characteristics, and we would like to be able to estimate the error variance. And the data sometimes could be sparse, so an appropriate way to approach this is a combined analysis that has both. How would that fit into computational psychometrics? Well, in this type of models, we could have different types of linking functions. And in some instances, this linking function can be from machine learning. Also, these models may be part of, as I mentioned before, this full dynamic testing instrumentation, if you want, and therefore many of the features in the model will depend on how the data has been aligned, how were the features of the items obtained, and what are the properties of the items, and how much information can we get about people. So it's just an idea, and now I would let my colleague Bert Settles, who has been with Duolingo for a long time. He's actually, the Duolingo English test is his brainchild. So I would let Bert talk about how he developed this test that is really different from the traditional assessments.
Thank you, Alina. So I'll kind of walk through this as an example of some of the principles that Alina was talking about. So in traditional test development, what normally happens is you have a bunch of domain experts write a bunch of test items, then you administer thousands of pilot administrations to hopefully subjects who fit the target demographic for the test, perform psychometric analyses to get item fits and things, and then this ultimately determines the pool of test items, be it a fixed form test or a computer adaptive test. And one of the limitations is this is very time consuming and expensive. It both slows down how quickly you can create a test. It inhibits the item pool from being very large. And it also causes problems with like constantly, or a challenge to constantly refreshing the item pool. And hopefully a lot of people on the call today are familiar with the Roche model, which is a basic item response theory model where we model the probability of a particular examinee getting an item correct is a function of these two delta and theta parameters of item difficulty and examinability. And from a machine learning perspective, this is identical to just a binary logistic regression with exactly two feature types, examinees and items. And in a more, again, traditional test environment, you would, after you get these item fits and user fits, you can kind of throw the thetas away and then administer a new test with those items, and the pattern of what a new examinee gets right and wrong then determines their test score estimate. And one thing that we were asking, there's another limitation to this too, where the scores are generally, they need to be interpreted in a norm referenced way as opposed to a criterion referenced way. And so one question we were asking is, can we bypass this expensive step using machine learning and natural language processing if we have a criterion reference like the Common European Framework of Reference, or the CEFR, for building a language test? So that's what we did. Just as an example of one of the many item types that are in the test, this yes-no vocabulary test, it looks a little weird, and it is, but it's also a lot of fun and highly predictive of both writing, reading, listening, and speaking skills. But the basic idea is you're shown a set of stimuli. Some of them are real words like positively and apply, and then mixed in with that are some English-like pseudo words like war dies and bricken, which kind of follow the morphological and phonological rules of English, but are not actual English words. Linguists would call these accidental deletions. And then using the CEFR, which if you're not familiar is a 6-stage kind of descriptive framework of language proficiency, where A1 You can do very basic survival English, like greetings, describing people, ordering food and drinks. B2 is where you start to transition into being able to study in an English medium university. For example, you can understand complex texts, argue viewpoints. And what we did is we mapped this to the Duolingo scale. We just assigned each of these 6 levels to a 100-point scale, and then use machine learning to project items. We had thousands of English vocabulary words tagged to the CEFR, and we're able to learn models to project words onto this scale. So box and food are very short, high frequency, basic English words. If you move up, you know, obfuscated and crepuscular are very, you know, academic, obscure words. And interestingly, we use a neural network to generate a bunch of pseudo words. We can apply the same machine learning model to words that don't actually exist. So thelf and dak don't exist, but if they did, they would probably be A1 level words. They're short and Anglo-Saxon looking. And as you move up, contributory, trumplication arguably is a real word now, but those are like longer, more Greco-Latin, and would be less frequent words. And importantly, in a computer adaptive environment, we would ask students to be, to discriminate between box and food versus thelf and dak, or addicted and machinery versus tractical and scrampy. And that way they're testing their ability to discriminate real and pseudo words at a given calibrated CEFR band. And we didn't have to do any pilot testing to do this. So the relationship, this is preliminary work before, as we were building the test. These are the expert CEFR judgments on the 6 points. These are the predictions on the 100-point scale. It's able to make predictions kind of in between values as well. And you can see there's an extremely strong correlation between expert judgments and what the machine learning model learns. I'm gonna, for the sake of time, kind of skip over some of those outliers, but we repeated the same process for all the different item types that are in the test. So it's not just this kind of vocabulary game. There's also other item types that have been studied for decades in the literature. They can be automatically generated, and then using a similar process to project them onto our CEFR derived scale to evaluate reading, writing, listening comprehension, and speaking, etc. Here are some results for a full text model that we used for some of these other item types. Again, very strong predictive ability. Now, one question is, once we put this test, this alternative form of pilot testing where we use a machine learned construct of the CEFR, how consistent is that with what would have happened if we had done a more traditional pilot testing route? So what we're looking at here, it's not a perfect experiment, but after about 20,000 administrations of the Duolingo English test, the scores that were assigned are on the horizontal axis. And then what we did is we kind of like threw away all of the information that we knew about those items and administrations, fit a more traditional Roche model to the data, and the theta estimates are what you see on the vertical axis. So basically, there's an almost perfect correlation between these two approaches, which provides some evidence that our alternative form of pilot testing is valid. There's also a question of how this test is associated with other major English language tests like the TOEFL and IELTS. Those correlations are quite strong and in fact on par with or better than these two tests have with each other. In terms of reliability, split half and test retest reliability are both very high, especially for computer adaptive tests. And another advantage is that because we're able to automatically generate all of these items and automatically calibrate their item difficulty parameters using this machine learning alternative kind of form of pilot testing, we're able to generate huge item pools, which severely limits the exposure rate and the exam overlap rate, which is very important for item security in a test like the Duolingo English test, where anybody from anywhere in the world at any time can take the test. They don't have to schedule ahead. They don't have to go to a test center. It's a very different kind of approach to the security protocols. And maybe for the conclusion slide, I'll hand it back to Alina to wrap us up. And I think we're still.
Thank you, Burr. I believe you see this is really just a taste of what the test is. I would invite you all to check the website for the DT and read some of the reports that are available and the user guide. But you can see that it's definitely a different test, that it has been built using a different approach from the beginning with item development to tagging and to scoring. However, Burr has been working really hard, and the team as well, and now that I also joined, we are really working on putting a psychometric framework in order to, on top of this, to meet the standards. So in conclusion, I would like you to get to know, to learn more about the test, learn and see how rigorous it is. And we are working, the teams is working really hard on showing an evidence and share it with everyone that is a reliable test, valid, secure, efficient, accessible, and comparable with other tests. For the sake of this presentation, I would say the most important part of this conclusion is that it really illustrates the blend of AI and psychometrics in computational psychometrics. So I started computational psychometrics when I was on the side of psychometrics testing industry, trying to bring in artificial intelligence based methodologies. Now I'm on the other side, and this is really exciting. So I'm really happy to have the opportunity of sharing this with you all today. Thank you. The next slide, please. Oh. It's okay, thank you.
Thank you, Alina and Burr. I believe next up is John Whitmore. I think John's ready.
I am ready. Let me share my screen.
And this, Alina and Burr, just so you know, on chat, someone said, can you repeat, type in the website address again? I don't know if that is referring to the Duolingo website. So if you would just, you guys put it in chat, that would be great.
All right, great. Well, first, thank you very much, Alina and Ada, for inviting me to this presentation, to this panel session. Look forward to presenting a little bit of work today. So I'm going to be speaking about learning analytics, and I think what we're seeing right now and some examples of making this transition from prediction to action. Can you see my slides?
Yes.
Okay, great. So just a definition, some paradigmatic definitions of learning analytics that I like to use that show a distinction from other forms of educational research. And here's two of them. I won't read them to you. You can read them faster than I can speak them. But the first one comes from the first LAK conference in 2011 that was held in Banff. And you see there the group of researchers that got together kind of came up with this definition. They'd been working in disparate areas and said, what is this area? And kind of came up with this definition. And I've highlighted there a couple of the distinctions in case you're not familiar with this. And I think with the area of learning analytics, and I think that pull it out. One is, you know, that we want to understand learners and their contexts in which learning occurs. And then there's this kind of focus on understanding and optimizing learning and those environments. And then the second definition there speaks about looking at, number one, usage data. So thinking about what Alina earlier called process data that's associated with student learning. And then seeing again this idea of observing and then understanding in order to enable interventions. And I'd say, you know, on both of these, there's this focus on the process, there's this focus on the context, as well as the learning itself, and thinking about what we can do to improve the situation of learners. And I think that we've been able to make very good progress, I think, so far in learning analytics on kind of one half of that equation, that we've been able to predict student success and failure with very high accuracy rates using multiple methods. And especially, I think, in the times of COVID, we haven't seen that impact yet, but the increasing this integration of educational technologies into, and I put in air quotes here, conventional learning environments. You know, that means something quite different these days, as many people are learning at home or in other contexts. But even before we had the pandemic and dealing with the pandemic, the increasing integration of educational technologies like Duolingo and like other kinds of technologies has made it possible to collect process data for a diverse range of learners. And I think that, so we've been able to do that, use that to identify in several studies that I and my teams have conducted. Between the weeks 2 and 3, we seem to be able to get considerable accuracy such that we can identify learners who may need intervention. But I think using those to improve learning outcomes, to make interventions, has had much less attention. And I think part of that is because it requires identification of underlying constructs and student motivations. There's been initial work to do that that's been largely around self-regulated learning, especially for students in fully online courses, recognizing that that's kind of a major aspect of whether those students succeed or fail. So I think here kind of a key approach for computational psychometrics is to identify other constructs that may underlie clickstream activity that also scale to other courses in multiple contexts, as well as analyzing the interventions and the results and outcomes of those interventions. So I'm going to speak about 2 studies today that are highlighted on the right-hand side. You see the titles there. One's called The Constructs Behind the Clicks. I'll begin with that one. That's the stealth assessment study that Ada referred to earlier. And then another study that we conducted at Blackboard around notifications built into systems. I have a disclaimer at the bottom, conducted these studies with Blackboard at ACT that I'm no longer with, but the studies are Creative Commons licensed, so we can talk about their results in the process as well. So here is a study that we conducted with ACT and ACT Next called Predicting Social Emotional Skills in Course Grade with Learning Analytics. So ACT has an assessment that's called the Tessera, and it's been demonstrated, and there's a lot of attention to social and emotional skills, and they have been found to strongly predict, here we have on the left, academic achievement, career success, lifelong well-being, and they found that those are as important as academic skills to helping students actually succeed, to meet their goals, and to persist to the end. And so ACT has created an assessment of them, and you see the constructs here in the middle of this page. And so you see that we've got grit, we've got teamwork, resilience, curiosity, and leadership. I'd call attention that grit does not actually meet the Carol Dweck definition of grit. It's more persistence, goal striving, reliability, dependability, attention to detail. So that's one of those kind of time on task measures if a student does and plans, it's planful and intentional about their work. And then you see some of the other items that kind of meet what you might expect. So we knew that these skills actually, let me go to the next slide, those skills actually measure things that are important at the end, but what was not visible was the way in which those actually make that difference in student learning and how those are manifested in daily behaviors. We didn't know the kind of way that those can be seen. And so we conducted a research study to look at how and whether we could observe those in authentic learning environments. So here is a couple of, there's 4 research questions underlying the study. For the sake of time and doing 2 studies within the time I have today, I'm going to just talk about the first 2 research questions. So the first is, can we observe these social and emotional skills through the behaviors that are recorded in online learning environments? And then how accurate are the predictions of social and emotional skills compared to the predictions of student course grade using these behaviors? So here's a summary of the methods that were used. I also skipped, we're going to talk about 4 classes that were in higher education. They were at a higher education institution, University of Maryland, Baltimore County. We had a variety of enrollments from about 50 to over 300 in the classes. Quite diverse audience, working class audience. And so we had those students opted into this study. All of and these classes all use a learning management system. And so we took the data, we had the students, they opted in to take the Tessera test. And then we had their course activity from the learning management system. And we pulled those data points together to see what we could find in terms of that prediction. And here's a summary of those methods here. We manually mapped that data from the learning management system to categories that we created through expert knowledge. We calculated then count, standard deviation, duration for each of these items. And you can see here how the kind of manually mapped that data went from 110 items down to 21. And then we had kind of 3 varieties of the way that we created that data, went up to 63. And then we did factor loading to determine kind of the essential data points from that. And then did also sequential data mining to come up with learning tactics. Again, that's in the full paper. We won't talk about that today. And then we did correlational analysis between each of these items in 2 to 4. And then the social and emotional skills and student grade, and created predictive models using GBM. We also looked at using logistic regression techniques and found gradient boosted, beat them by quite a bit. So stuck with gradient boosted techniques, machine learning techniques for that. And we also analyzed to ensure that we did not have bias based on underlying student characteristics, gender, race, ethnicity, socioeconomic status. So let's look quickly, we'll look at the correlational analysis as well as the predictive models. And there's a couple of so to begin, chemistry was one of the classes, had the largest enrollment, the largest participation, and the highest use of the learning management system. Here's a chart showing the correlation of individual items with student grade. We're going to look at first the correlation of this class, compare it to other classes, and then we'll look at the relationship with social and emotional skills. So here, the most important thing for student grade, the highest correlation here, and you can see these are about small to medium effect sizes, 0.358, was the number of times a student used the discussion board. And then the kind of highest correlation values are also time spent and variability of time. We also, as part of the study, we had a conversation with the instructor of the course. Interestingly, she said, I don't know why that's the case. I don't actually use the discussion board as part of my class. It certainly is not graded. I wonder why that could be. And then after further reflection, she said, well, that's where the students who are reading ahead, who have questions, the kind of eager on-task students, that's where they interact and engage with me a lot more than other students. So it was a surprise to her kind of overall, but it revealed, again, the way we could find how those students are interacting and using those tools. And then you see here just kind of a note, number of sessions, time spent on lecture activities, announcements, and a couple of other things. Interesting to me also, gradebook was very low. In prior studies, I found that to be quite high. So this shows the things they were doing, and this is in the LMS had, again, these strength correlations, small, medium correlations with their final outcome. The interesting thing here, I think, on grade, if you look at the comparison to the other classes, I know that the font size here is a little small, apologies for that, but here's a math class, 0.3, and for all the other classes, the number of sessions, that is the number of times people logged in, had the strongest correlation, but then everything below that is different, which depends on the variability of what happened in that class. And we did one set of mappings, and then we ran this and the correlations across them that was not, we didn't have to humanly map these and look at these. So this was the way that was determined with with one set of mappings, and then we were able to kind of abstract that and see this variability between classes. So we ran one set of correlations across all of the classes, and to me this shows a little bit of the authenticity of this work related to those classes. And then here, what we really didn't know, this class was not designed with grit or any of the other constructs in mind. Going to grit, we see grit had the strongest relationship, the degree of grit to grade. And then we had very different items. The variability of time on assignments was the next strongest. Again, not super surprising. If you turn in your assignments, if you turn in your assignments, that really reflects whether a student is doing things on time as they are kind of supposed to do it and spending time in the appropriate ways. And then we get to session, time on lecture, task, activities. And again, this was an exploratory study, so seeing the kind of things that were indicated really gave us good confidence that this was reflected, that grit was being reflected in what people did in the class. And again, when we go to the other classes as well, we look at this, the items that are listed in the correlations are quite different. For math, time on information, time on general content, time on information, and these are lower effect sizes, lower correlation strength, but still a significant number of items. And then some of them here were interesting where we have negative correlations. We can't quite explain that. Time spent on assignment and number of attempts on assignment. Perhaps they were doing some of that outside of the LMS. We're not quite, can't quite explain that actually. So interesting things to find. And again, here we've got time spent. The number of sessions was the most important, the highest correlated in physics and psychology, but we have other items here as well. And again, they vary based on the class, but they all kind of have face validity, that there's something that would relate to this time spent and this planful intention of the student. So looking quickly at predictive models. So these are predictive models, cross-validated root mean squared error on the left-hand side, our y-axis, and then the weeks in the course are along the x-axis, and then the color of the lines is each individual course. And here we see an interesting thing, that the grade, you can see here is the start. We looked before the start of the class because we had the data. And so we see that it actually, at the start of the class, we see an immediate trail off, especially for grade, or a reduction in the error. And then after about week 5, it largely levels out. We think in the math class here, there's a little bump. Students start studying for the final exam quite a bit. But you see that the accuracy improves as time goes on. Interesting difference in finding we have strong accuracy for each of the other predictive models. But after a little bit after the start of the class, it's actually consistent over time, and does not change with increased activity, which, again, we can interpret that multiple ways, but for us, that reflects that the expression of these constructs was consistent and did not change over time. They did not increase their teamwork, their grit did not increase, so it was being reflected in that behavior. All right, I've got a couple more minutes to do my next presentation, so I'm going to zoom through here. So a couple big surprises for us: the consistency of findings despite the high variability in LMS usage across the classes. This face validity and the variability of the correlations was surprising to us, and this value of faculty feedback to interpret the data and findings, which I mentioned. It's not really a surprise, but it was a very strong takeaway. All right, so I'm going to mention quickly here student notification research. In summary, there's a lot of ed tech companies that are creating notifications going directly to students. There's quite a bit of concern around that, creating self-fulfilling prophecies for students who have low self-confidence, and we don't have that much evidence around how those work. We sought to look at that before creating interventions, actually for interventions that we had put in place at Blackboard that went on and that were turned on by default for students. These notifications included nods and nudges. So nods to do something that you're doing a good job, or nudges to do something different. And so we deployed this within the software and then had analytics to study the way it was used. You can see the research questions here. What we really wanted to know, the basic, was, were students interested? Would they use these? And then would it make a difference in their learning outcomes? And I'm just going to show a couple of things here that we had 5 clusters of students from low performers. This was all notifications based on grade, notifications based on activity did not trigger. And the biggest I think one of the things we found here was open rates, that there's grade in the lowest 10%, and then we had grade in the highest 20%. We developed these really with struggling students in mind. However, the students who used them the most, not too great of a surprise in retrospect, were the students with the higher grades. And they continued to open them even though they repeatedly received these recommendations. Another thing that we found, and there's a lot of variability in the literature, or some debate around this, was whether comparisons between students are actually helpful or not, or it's better to give students information relative to themselves. If you look here, you can see a high variability. These are the groups of students, and then each of the notification types. And you can see there's quite a bit of difference between the open rates in these notification types. But when you take them out, what we found was that the notifications that students looked at the most were those that showed them their performance related to other students. So again, first we see what that interest is, and then what we wanted to find out was whether that makes a difference in student learning or not. What we found, we could not find that relationship, given the variability in the courses, the variability in the data. It was not, there was no significant relationship. It was a real spaghetti plot of the data. But what we did find was it looked like the students, looking at this over time, that one way the students that were in this malleable middle, receiving multiple notifications, as well as the higher performers, that they had a lower relationship, and the students who were improvers or decliners, when they were spending time in the LMS, they spent more time on these notifications relative to other students, which again, that awareness suggests that they were at least paying attention to it and it could have an impact. And I think, that's the first stage of this question, which we wanted to research more moving forward. So again, I'm a little bit over time. Thank you, Ada, for not cutting me off the stage, but wanted to show a couple of these examples of computational psychometrics in learning analytics. So thank you very much.
Excellent. Thank you, John. And I see that you have your slide on your website. So if you would like to share and folks want to dig in, would you mind posting that link to the chat so folks can kind of get to it? So next up is Yuqi Huang. Yuqi is going to share his research on automated content generation. So Yuqi, take it away.
Hi, thank you, Ada and Alina, for inviting me to attend this seminar. So I'm going to share my screen and start a presentation. So if you guys can see my screen, I'm going to continue from here.
We can see. Thank you, Yuqi.
Great. So today I'm going to introduce Sphinx, an automated generation system for English reading comprehension assessment. And this work was done in AI machine learning group of ACT Next of ACT. And at that time, we've got a lot of help, support, and instruction from Alina and other colleagues of ACT and ACT Next. So we're talking about content generation system for education. So at first we need to ask why. Because nowadays we may use, say, like online learning platform for students. We need a tons of material. For example, the English reading comprehension passages designed for students. If from a traditional way, we have to write those passages from scratch and hire a lot of very skilled experts to do so. It's very time demanding and very sometimes tedious and need a lot of very highly skilled experts. So what if we can do it automatically or semi-automatically? So this is a very challenging problems even for human being. So how can we do it by using a machine? So the good news is that recently, because of the advancement in the field of machine learning, we have a lot of ways to process information from text and other modalities. And in this way, we can borrow a lot of techniques from this booming field to help our to do this job for us. We can see a lot of applications, for example, Apple Zero and Google Translation, and so many applications that benefits a lot from language, so-called natural language processing. And so in this work, we use natural language processing to push forward this target. So we call it Sphinx. So why we call it? Because we are going to use machine learning, but right now the machine learning is not ready to fully automatically generate content for education. So we do it like a hybrid way, where we combine the effort of human being with the intelligence of machines. So that's the way we do it. And in this system, we have a lot of components like archiving, a lot of documents. We do summarization, topic modeling, recommendation, paraphrasing, item generation, and finally do the delivery. So all these are like the major components of our system. So the benefits. So you may say, okay, as I introduced, we can use all these kind of generated content or passages in the adaptive learning platform. We can create APIs for different domains, for different specific applications. All these are the motivations or benefits. But also you can also think about, we can put the automated content generation in the ecosystem or the automated world. See, we can share the information between the ACG, the automated content generation, with automated item generation and automated scoring. So in this way, we can form a circle to boost the whole system and the ecosystem and the whole industry. So this is the bird's eye view, flow map of a Sphinx framework. So at first, we have a lot of source documents, see hundreds of thousands of them, and we do summarization. And then by machine learning, we can do topic modeling. Topic modeling means here means sentence clustering. We cluster all the sentences in our archive into small clusters according to their topics. And we extract topic phrases extraction to showcase to the users so they can select their favorite sentence to start an article, or to select a sentence to continue the composition of the article. And we also have a module called paraphrasing, because in this domain, the writing, we should avoid some the plagiarism problem, because we cannot use their work directly. So we need to do the rewriting. So here comes the paraphrasing module. The sentence recommendation of generation. This means after we select some sentences, this module can provide us a lot of options to go forward from either the source document, archive, sentences pool, or generate some entirely new sentences for us to choose. And finally, we can generate the passages and also generate items for users to use. So to fulfill these targets, we created an online service in ACT Next. So this is the interface you can register and use inside of ACT. And especially for those content specialists, they can try this system to give us some feedback suggestions. So the first component would be summarization. So you may ask why we need summarization, because for each passages, per each passage in our pool, sometimes it's very long, and to provide some very short summaries to the user, that would be very good, so they can review the content very quickly. So what we use is a kind of technology named sentence extraction technology. So we can extract the key sentences from each article to generate a summarization like contains only 30 or 20% of words, the number of words from the original article, but contain almost all the key information. So the users can read quickly and to get an idea what it's about. And topic modeling, because in our system, for example, if an article, a writer, they want to start writing about a specific topic, they need to start the article, start the composition from one sentence. So how did she or he start the writing? He has to think about some topic, specific topic, and start from there. So this is why we do the topic modeling in the backend. That means after we get so many articles, we do the sentence clusters, do the clustering. So this is some like unsupervised learning. So we can divide different group of sentences of different topics into to organize them in a way so the writers can see them. And we use different sentence clustering algorithms. So we found out the k-means would be the fast one. And we also use several different topic phrase extraction method to extract the very representing words and phrases from the cluster of sentences. See, you can see, so let me go back. Yeah, you can see from the right-hand side, this is basically our interface. So you can select the topic 3, for example, Mountain Washington Observatory, and whether the summit forecast, and it will come up some sentences relating to this topic. And you can choose one to start a composition. And another component is sentence recommendation. So this is interactive and semi-automated automated system. So the thing we do is that we provide options to users. That is, after we choose a series of sentences, the system will update the options for next sentence, either from the pool of archiving sentences by computing the similarity of all the content we have written before this sentence to provide some recommendations. And also we provide a function called natural language generation that is based on the content we have chosen, we have written, so we can generate a whole bunch of sentences coming from nowhere, not from the archiving sentences. So in this way, we gave the users, the writers, more options to go forward. And paraphrasing. As I introduced, paraphrasing is a module to do rewriting. So here we use a method of so-called double translation. So that means because think about you translate English to another language and you translate back. The meaning would be very similar, but the language could be different. I mean, the two English sentences from the source to the target. So what we do is that we select a list of different languages, say like French and Chinese, Japanese. We use them as the intermediate language to do this like a double translation, and we will rank the results of this double translation by semantic distance and also the wording distance. That is whether they look like different, but actually present the same meaning for users to choose. And this is the final interface for the composition workflow. After we choose the sentences one by one, and we can choose for introduction, body, and ending. And after all this work, we can generate one completed article for English passages. And this one is a component we just integrated, Aegis. This is ACT English item generation system. And we integrate this component into Sphinx. So every article generated by Sphinx can generate different sets of items immediately for users to use. The overall architecture. So as I mentioned, we hosted this as an online service. So we have a front end interface written by React, and we have a backend server managed by Django. And for each component I mentioned, we have an independent instance server hosted on Amazon AWS for clustering, recommendation, summarization, and paraphrasing. So some next step work we can do. We are actually collaborating with the content team. So for them to use to give us suggestions and integrate extended Aegis functions. We have also some feature additions we would like to add. For example, sentence structure, modification, style transfer, transfer the difficulty of the article we generated. Also, we would like to push forward the operational use, so we can use the articles generated by Sphinx in different ACT tests. Maybe not some like a very high stake text, but starting from the low stake text at first. And actually, I host like a video demo here in the YouTube, so you guys can take a look. So you can see anyone can log into the internal system, and these are the archived articles. Can choose to start and view the content and the summary. And the summary will be generated instantly after you open one article. And the composition, if you click, and starting from, for example, the introduction. And you can choose from the topic automatically generated from the source archive. And then choose, like, for example, one topic seed sentence to start the composition. And our system will be freshed here to provide some like next sentence options for you to choose from the archive or from nowhere. And this process can continue again and again to the final point of the introduction, then the body, then the end. And you can also see that for generated draft on the right-hand side, we can make modification, all kinds of modifications, in every step. You can delete a word, you can do paraphrasing here, like here.
Yuchi, I don't think we can see the demo. I
Oh,
think
you can,
no,
oh,
we
I'm sorry. Let
have a
me,
different screen. Yeah.
oh, let me reshare it maybe.
Perhaps if you have a link that, or just the video, that could be useful too.
Yeah,
Yeah.
I have a link. I'm sorry. Maybe I just only shared you see, this is the video. It's like only 1 or 2 minutes, so I can, yeah.
It's
So
coming
if
up.
you guys are interested, you can, I can share the video link with you, and you can try it after this presentation. Yeah, basically, this is my presentation, and thank you guys for your interest.
Thank you, Yuchi. And if you would type the link to your YouTube video on the chat, then folks can get to it. Thank you. All right.
I'm going to do so. Yeah.
So next up is our discussion comment and feedback for the researchers. So Bruno.
All right. Can you all hear me?
Yes.
Yeah, excellent. Let me see if I can share my slides here.
We see your screen.
Full screen?
It's yes, full screen right now.
Fantastic. Thank you very much. And if everyone can hear me, thank you all for waiting this long. I promise to try and keep this. I have a lot to say, but I'll share my slides with all of you right after the presentation, so you can. I'll give you sort of a cursory journey through. I am. My name is Bruno Zumbo. I have these various titles at UBC: Professor Distinguished Scholar, recently named as a Tier 1 Canada Research Chair, and I hold the Paragon UBC Professorship in Psychometrics and Measurement. Paragon is a subsidiary of the University of British Columbia. I want to congratulate, let me see if I can adjust a bit more of my, see a bit more of my screen here. I want to congratulate session organizer, the chair, and presenters for the thought-provoking nature of their work. Alina, thank you for organizing it. Ada for chairing it. Yuji, Alina, Burr, and John, outstanding papers. I believe that the work of this caliber that challenges our thinking and many of the orthodoxies in the field deserves serious consideration. And it's not the kind of serious consideration that you can do sort of on the fly peer review of the discussion. So this is going to be a blend of comment on their work and reflections, what ideas that were stirred, that their work stirred in me. I'll be frank with you, not a lot of work that I read these days stirs me. We're in a sort of a filling in the blanks, but some of it does, and this certainly does, and I strongly recommend that you all read this work and get into it a little bit. But let me give you some of my comments. Well, let me say a few comments on each of the presentations first. So the first by the paper by Alina and Burr. A couple of themes that really struck me, I thought I want to highlight for all of you, is that these emerging trends in assessment are AI powered, they are algorithmic, they're in some senses, some of them are data hungry, but not all of them. We saw that the power is in the integration of the AI tools. What I loved, and I've always loved about Alina's thinking in a variety of areas that she's worked on, wherever she seems to go, she seems to make an exciting contribution that changes the field. And so, and this has gone on with the area of computational psychometrics. What is essential to, I have been a critic of what we're going to call, what I'm going to call unprincipled, blind, algorithmic assessment, and you're going to see it in my comments. And I remain a critic of that. And I think my colleagues on the panel today, I think all of them would agree. Blind, data-driven algorithmic black box stuff can't go on. And Alina's is far from that. Alina's been advocating that psychometrics, that it be psychometric centered, theory-based, and data-driven. And in fact, the first two are the fundamental principles of what I would think of as principled assessment of this sort. So Alina, I tip my hat. I always get a little bit of a deeper understanding of what Alina is doing. A couple comments on John's work. Making the learning analytics, making the transition from prediction to action. I read John's presentation and the related papers he sent. They were really helpful to me in understanding learning analytics. John's sort of pointed to this in his presentation. It's been a term that's been confusing to me. Clearly, I think it's also been confusing to some in the field of learning analytics. That's not unusual. It's a field that's sort of growing, trying to find its feet. It's, you know, the coming together of different ideas. So John's work in papers here and his presentation did help me a great deal to get an understanding. And what I really liked about it is the rhetorical turn to action. And that I thought was really cool. I also was fascinated by the consistency of the findings, despite the fact that, as John says, there's a fair amount of variability in the LMS usage. My own preference is explanatory, and I'll say a few words about that later. Some individuals in the learning analytics field are moving that way. If I can say anything about the field and how it contributes to assessment, learning, and such, the more explanatory, the better. I've been a long time reader of the work of Judea Pearl back when he was fashionable among statisticians before then, and he was doing AI kind of work. Variations on Bayes nets. You go back to what people like Judea Pearl was saying, is trying to find, if you wish, explanatory models. Just algorithms on their own it take too much advantage of chance data. And I think what I loved about the learning analytics in Alina's as well, and we're seeing the third paper, is that this work is more principled and I'm hoping a bit more explanatory as we move along. But I really love John's ideas. Yuji's work, we were introduced to Sphinx, which is sort of a human AI hybrid system for the scalable production of reading comprehension passages in English from reader samples and prompts. That scalable part, I think, is the important for me. I mean, you know, other approaches have been developed over the years, as I understand it. I'm not a specialist. I sort of lurk around the boundaries of what's going on in that area. As an applied mathematician, I'm always fascinated by some of these algorithms and these approaches. But this work that's very important for Yuji, for me, is that it's scalable and it's groundbreaking. And in my opinion, it may well even be the first. I don't know, because it is a groundbreaking natural language generation system designed to create reading passages in this really computationally efficient manner and a very large number of learning and assessment contexts. So you'll see that these papers are engaging. They're very exciting. Whoever's moderating and chairing, as we run out of time and get closer, please know we'll be serving lunch as things go on. My presentation will finish around 3 o'clock this afternoon. That was funny. I'm sure all of you at home are laughing. I'll put my hand up when something is supposed to be hysterical. But jump in at some point if I'm dragging on too long. But this I thought was exciting, and the other work that's going on is in all of these 3 papers is really, in my opinion, fascinating. And before I turn to the next part of it, I want to highlight that I come to this from someone who has been and continues to be critical of it. And the critical element is around the blind sort of faith-based algorithmic use in assessment. None of these approaches reflect that. This is a model of the way we should be doing it. Modeled, in fact, and driven importantly by Alina von Davier's Computational Psychometrics. So where do we go from here? I'm enthused, I'm excited, I love it. So let me give you a series of reflections, sort of 0 to 4, very briefly. there to trigger some thinking, give me an opportunity to vent a little bit about some ideas, and also an opportunity to tell you about the things that were stirred up. I had to limit it to 4. There were 123 on the first version of these presentations. And well, maybe not 123, but near. So I chose the the 5 ones that I really want to highlight. First is that taker response data is needed. This may seem self-evident, or at least it was until recently. Test-free test scores. Test-free. So you get people who don't take test scores get test scores. Fascinating idea. Actually terrifying idea. It was recently seen in the UK with the A levels as a variation on that. I have to be cautious. I'm in Canada. We were once a colony. I still, in some way, report to the Queen or a Queen, and so off we go with test-free test scores. No one in this session is talking about that. The first thing that struck me, of course, is all the papers here talk about have some notion of measurement error. Implicit or explicit in their models, and this could be measurement or misclassification error. It's a core feature of all of these papers. The problem I have with test-free test scores is, first of all, I don't know how to quantify prediction error, but we can kludge one up, we can put something together. Unfortunately, the ones that were used recently were way off the mark. In fact, the prediction error there was probably much larger. A corollary of this is that we really never have enough data. In 2007, in my chapter on validity in the Handbook of Statistics, the handbook, a volume dedicated to psychometrics, one of the things I talked about is we never have enough data. In fact, the worst thing about it is we really never have the data we want. And I'm a little bit always alarmed. I mean, Chris Anderson's quotation, who's the former editor for Wired magazine, is often talked about. And what Anderson and others, the sort of the high priests of data, of model-free data, make claims like, oh, massively data is abundant, et cetera, et cetera. Well, not for our task, right? I don't agree with Anderson. Anderson wasn't talking about it in terms of the context of assessment, but I've heard on more than one occasion the similar notion that occurs, that's talked about in the hallways, at conferences, at universities, when I'm invited around the world. I was lecturing in Europe on this notion, oh, well, you know, we happen to have some data laying around that's related to what we want. We'll use that. Let's just do some predictive device, predictive algorithm, maybe structured or unstructured. We'll extract features or latent variables, whatever you want to call them. And so I disagree with that whole tradition. Anderson is probably the sort of the main faith, or originally was anyway, some years ago. Couple of other ones that, you know, here's another reflection that really sort of struck me, and it really was the song, "The Times They Are A-Changing," or A-Changing. Bob Dylan in '63, those of us of a particular vintage will have heard that, perhaps under particular influences at the time. But this is sort of anti-establishment feeling really does occur in psychometrics. Orthodox psychometric theory and modeling has long been charged with neglecting reality. In fact, you may even say orthodox psychometric theory, as advocated by people like Zumbo, have long been charged with neglecting reality. And I'm still struggling with, you know, test theory models. There's a very mathematically laden paper just appearing this fall in the Journal of Mathematical Psychology by my colleague Ed Kroc and I, in which we use measure theory, which is an area of mathematics, which I studied in, and so did Ed. Our doctoral work, decades apart, but using a type of area of analysis to look at the statement X equals T plus E and all the various statements of them, and how does one declare classical test theory? And it's along the line of a series of work that orthodox psychometric theory, like myself, I'm still working on a measure theoretic test theory, and there's a paper of mine forthcoming laying that out further. But the times they are changing. There's algorithms. There's a lot of anti-establishment. There's two reasons to keep this complaint at the forefront of our minds. First, the criticism is frequently made, frequently acknowledged, and just as frequently ignored by many of us, and I include myself. So orthodox psychometric theory and modeling has long been charged with neglecting reality. Second, and more importantly, the last 20 years has been massive developments in data-driven algorithms, virtual learning, and complex assessment environments. Another reflection that I want to highlight is that in modeling test and assessment data, the addition of an apparently weaker a priori structure to the actual data often produces apparently stronger a posteriori structure. And this type of modeling, and it does happen fairly regularly, it is really fascinating because we construct models for different purposes with different formalisms. You saw different kinds of models today. Some of them were actually statistical or mathematical models. Some of them are models in an algorithmic sense. What I want to highlight here, which is the right model, which is the true set of equations, in my opinion, is still that question is a mistake. What you can see is that you can take any set of test responses, test data, overlay assumptions, mathematical models, and extract, or in some senses construct, statistical information for assessment purposes. And that's been expanded now with algorithmic approaches. There was the notion of validity came through all of this. I have a particular view of that I've been advocating for some time. But a key thing to note is that we need to know what we mean by validity. If not, we don't know if we've achieved it. Now, I have no particular, you can adopt any of a variety of definitions of validity that are out there. Michael Kane's work has got a lot of wonderful traction, has some great value, but there's work being done by my colleague Steve Cerisi, there's Denny Boersboom, and others have views of validity. I have my own particular view that's very explanation focused. I've written several papers on it over the years. But a lot of this work is heavily model based. And so going back to the reflection 3 on models and imposing these a priori statements and a posteriori outcomes, well, this all is very heavily model based, including the work that we saw today and a lot of these blind computational models that they're not blind, actually, they're used blindly, they're not blind. The ones that are used blindly, they actually are also models. My own leanings are a combination of an ecological model, item and test responding, and explanatory focused view of validity. I think this will be of value to the presenters here. I think if we can gain explanatory understanding, that strengthens our conclusions greatly. It helps our inferential strength, which is really what the validity is. In a simple sense is let's bring this into a science. Let's develop explanatory approaches. Some of them be mathematical models, other types of explanation. There's even narrative explanations that are very rich and beautiful. These explanations are what drive validity. In fact, the explanation is what we're trying to achieve. I emphasize that the aim of validation, my own, is to identify the determinants, explanatory theory, or tasks, items, test score variation. The explanation is the basis of any strong validity claims. I'm not the first in this. In fact, Cronbach and Meal was a particular kind, as I published a paper of mine, a chapter of mine in the book that came out of the Maryland conference, the University of Maryland conference on validity theory, edited by Bob Lissitz. In there, I talked about the fact that Cronbach and Meal, in fact, Denny Boersboom, myself, are really have different views of what explanation is. Well, Cronbach and Meal was, decades upon decades upon decades ago, a very particular view of what was explanation. Mine, Denny and I actually share a great deal in common in our views, and there is some slight differences in how we do it. In some ways, slight or not so slight differences, but there are some differences, but we do share a lot in common. The idea is explanation. I think that the individuals in this session would gain a lot if we can move from just prediction to developing some explanatory models. It is in the papers already. You can hear it in Alina's work with construct theory, with Alina and Burr. You can see it in their work. You can see it in John's work, in Yuchi's work. You can see these aims and works towards explanatory. I would say bring that up, and that drives it. My own particular leaning, I think, where all of these approaches can get to is to gain a lot from response processes, and that again is talked about in Alina's work in particular and others. And I'm not just talking about looking at the artifacts like response times and clicks and trust. I'm actually using that to look at it to develop some explanatory models. That's my big push for it. It's really not a new idea. Some of the work with this comes out of a slide that from a session actually that Alina and I were involved with. Alina was presenter, and I was too. Brian Maddox in 2016. What I'm trying to advocate is, in fact, of course, not an entirely new idea. A different twist on it. Crombeck in 49 in his text. This Paul Newton, a colleague out of the UK at Ofqual. I think he's still at Ofqual. Reminds us of this mental processes. Sam Messick in the substantive approach to the substantive evidence is really very much what I'm talking about, of course. I have a slightly different view. I expand this in a 2017 book edited by my colleague Anita Hubley and I, and in that we actually introduce a notion of how to think about and unpack response processes and response processes as validity evidence. And we go beyond just method. This is one of the problems of validity research. You know, it's factor analysis, it's multi-trait, multi-metric. No, those are methods. We need to know what is validity. And so we unpack that. And we look at the processes that underlie what people do, think, feel, or interact. And in an online environment, in computer-based or technology-based environment, we can now begin to draw this together. Brian Maddox, a colleague of mine in the UK, doing groundbreaking work in this area. My last comment is around consequences. And consequences of assessment are important. Again, I've written about this in some of my papers. It's contentious among some, whether it's part of validity or not. Everyone agrees to some extent that consequences are important, but in fact, I side somewhat closely to Messick in that it is central to validity. Artificial intelligence, machine learning, and really have brought up this algorithmic bias is the term that's used in the social media and in the popular press. I do think that needs to be thought about seriously. And just because we've imposed an algorithm, algorithms can, particularly if they are used in a particular way, can really, and by this I really talk about that sort of not model-based, in my opinion, unprincipled approach. It can, in fact, have, I don't think there's any dispute, there is a discussion about algorithmic bias. And so we do need to be aware of it. And like we talk about, in my opinion, in assessment generally, rather than simply guard against these harms passively, these algorithmic and machine learning systems should be used proactively to advance equity in assessment and testing. And of course, not too surprisingly, there already are industry standards in the software industry. I'm not an engineer. Back when I taught in the math departments in the dark ages, I taught a lot of engineers and was well aware of the IEEE and the ACM. And there are, this is a 2018 working paper that emerged out of workshop on software fairness. There's actually a lot of standards in there that could be used. And so we don't have to reinvent the wheel. I want to thank you all. I probably used more than my time. I don't know if you're still there or not. I want to thank you all. I will gladly share a PDF version of my slides right afterwards. You can write to me by email. If not, we can, I'm now going to take it back to the chair.
All right, well, thank you very much.
Ada, how many minutes was I over? I like to keep track of my abuse.
You're over a little bit.
A little bit? Okay. Good. I like it when it's quantified like a little bit. That's perfect. I like that. Thank you. And thank you all.
So we have a couple minutes left. So I think we have time for one question. And just so you guys are aware, there's some discussion in the chat on validity and learning analytics. So you might want to take a look at that as well. So any questions for the presenters?
Looks like we have a raised hand.
Yes, this is Chris with the GMC.
Hi, Chris.
Hi, Ada. And thank you very much for the presentations and also the very helpful discussion by Bruno. Alina introduced, briefly explained the introduction to the computational psychometrics, and one of the key features of the computational psychometrics was the psychometrics still being the centerpiece of that framework. And Alina, you specifically mentioned that the computational psychometrics is still centering around the latent structure or latent construct of that's being measured. And I believe Burr's example with Duolingo application probably is one of the applications of computational psychometrics. And when Burr shared the slide that showed the relationship between the IELTS data score and the Duolingo scores, I think that's very interesting information, but I don't know whether that's sufficient evidence of the latent structure being measured and you know, the Duolingo's score.
Alina, you're muted.
Thank you. Thank you, Chris. Yes, I mean, this is a good question, and I hope Burr is still on the line now. The idea is that we will be, there are other studies that have been done on the DT. One is about subscores, where the team led by Jeff LaFleur has been looking at the factorial structure for the DT. So there is some other work that has taken place recently, and there will be more to come. So I think there is now an emphasis on showing that, you know, how the DT meets the standards that we are used to in the other assessment.
I see. Thank you. And is there any additional work around the item level constructability?
No, not at the item level, but there is a paper on the subscores. It's on the website that we share with everyone.
I see. Thank you.
Stay tuned. There is more to come.
Well, thank you everyone for your participation and staying till the end of the presentations. It is 1:32, so we will just conclude this session, and thank you so much for your participation and listening to our research in computational psychometrics. Have a wonderful afternoon.
Thank you, and thank you, Bruno, for your comments. Very good points. We'll follow up. Thank you.